Have you ever wondered how we actually figure things out? I mean, really figure them out. From a new medicine that could save lives to the absolute secret for the perfect chocolate chip cookie. Well, it all boils down to running a good experiment, and that is exactly what we are going to crack open today. But here's the thing. What makes an experiment actually prove something? How do you know for sure that your result wasn't just, a fluke or a lucky guess? Well, like any good game, you gotta know the rules. And the very first rule is understanding who the players are. And that's our mission today. It's actually pretty simple. We're gonna crack the code of pretty much any experiment by learning how to spot its most important parts. And scientists have a name for these parts. They call them variables. I want you to think of any experiment like a play. And in this play, there are three main characters. Once you know who they are and you know what their jobs are, you can follow the plot of any scientific story out there. Okay, first up, we have the star of the show, the independent variable. This is the one, and I mean the one and only thing that you intentionally change. It's the cause you're testing, it's the thing you're poking to see what happens. So, how do you find it in the wild? It's actually super simple. You just have to ask one question. What is the one thing that's being changed on purpose here? Whatever the answer is, boom, that's your independent variable. Next up, we have the character who reacts to our star. This is the dependent variable. This is what you watch, what you observe, what you measure to see if anything happened. It's the effect, and its outcome literally depends on that one change you made. See how that works? And yep, you guessed it, there's another super simple question for this one. All you have to ask is, what is being measured to see the result? That answer right there is your dependent variable. And finally, we have the all-important supporting cast, the controlled variables. These are all the other things, all the other conditions that you have to keep exactly the same. And why? Because if you don't, your test just isn't fair, and honestly, your results are pretty much meaningless.
And the question to find all of these? It's the easiest one of all. You just ask, what are all the things that have to stay the same to make sure this is a fair fight?
Okay, enough with the theory. Let's put these characters into a real-world situation so you can see them in action. Let's grow some tomatoes. So here's our mission. We want to find out, does adding more fertilizer actually make our tomato plants grow bigger tomatoes? It's a simple, straightforward question, right? All right, it's your turn. Put on your scientist hat for a second. Using our first question, what is the one and only thing we are changing on purpose in this experiment? You got it. It's the amount of fertilizer. Maybe one plant gets a little scoop, another one gets a big scoop, and a third plant gets nothing at all. That is the cause we're testing. That makes it our independent variable. Okay, on to question 2. If we're changing up the fertilizer, what are we actually looking at to see the results? What are we going to measure at the very end of all this? Of course, it's the size of the tomatoes. We're going to get out a ruler, maybe a scale, and measure them. The size of those tomatoes depends on how much fertilizer they got. So that's our dependent variable. And now for the big one, the final question. To be absolutely 100% sure that any difference in tomato size is only because of the fertilizer, what other things have to be identical for all of our plants? And this is where things get really critical. For this to be a fair test, basically everything else has to be the same. They all need the same amount of sunlight, the same amount of water, the exact same kind of soil. They have to be the same type of tomato plant to begin with. Even the pots they're in need to be the same size. If you change any of those, you'll have no idea if it was the fertilizer or something else that made a difference. You've got a busted experiment. Now, that might seem like a whole lot to keep track of, but what if I told you there's a simple, golden formula that makes it basically impossible to forget? Seriously. Everything we just went over, all those definitions, all those questions, it can all be squished down into one powerful little sentence. This is the ultimate cheat code for figuring out variables, every single time. You ready? Here it is. In any fair experiment, you change one thing. That's your independent variable. You measure another thing. That's your dependent variable. And you keep all the other stuff the same. Those are your controlled variables. Change, measure, keep. That's it. That's the entire game right there. So now that you have this awesome formula in your back pocket, let's just make sure it really sticks by looking at the most common ways people get tripped up. If you can avoid these, you are golden. The number one mix-up, by far, is confusing what you change with what you measure. Just always remember, the change is the cause, that's independent. The The measurement is the effect. That's dependent. The cause has to come before the effect. Simple as that. So here it is, your final take-home checklist. The next time you see a study or hear about an experiment, just run it through these 3 questions in your head. What did they change? What did they measure? And what did they keep the same? And just like that, you'll be able to break it all down.
So, I'll leave you with a little challenge. Think about your morning coffee or tea, whatever you drink. If you wanted to run the perfect experiment to find the absolute best way to brew it, what would you change? Would it be the water temperature, the type of beans, the brew time? And then, what would you measure? And more importantly, just how many things can you think of that you'd have to keep the same? You might be surprised.